record on this computer. Okay, now we're recording. Cool. Now I'm going to share my screen. There we are. And so there's our reference mode. And then I think this is where we left off last time. So just a quick review for everybody, including me, so I can remember what the heck we're doing here. So you see over here, you can make things bigger if that's helpful. So we're starting with 2 sectors. We brainstormed on the order of 5 sectors, and that's fine. In my experience, if you get a group into it and they're rolling, you don't want to start saying, oh, stop, we got enough, or, you know, with some caveats that if it's getting crazy, you want to stop that. But you want to let people talk, right? If you got clients, if you got a group model building situation, and you can always chop things back later. You try and keep them on task. You kind of try and keep folks focused on the notion that there's a problem statement here, and we're only interested in stuff related to that problem statement or the reference mode. But you don't want to, you know, if the snowball's rolling down the hill, you want to let it go for a while, right? So we had on the order of 5 sectors that were not ridiculous. They made sense. You know, logical arguments were presented. So we said, okay, let's keep that all in our hip pocket and let's pick 1 or 2 to get going here. And we kind of picked 2 because we're trying to illustrate some things here. So it's not really totally a unique situation. We're kind of simulating a unique situation, a unique model. But nevertheless, it's kind of close to how I think one of these things would unfold. So we have these 2 sectors, just to refresh our memories. We have a very lean and simplistic, almost a placeholder ADDX sector at the moment. That's the demand side. Remember I said, I like, as an economist, think about supply and demand, as well as stocks and flows and feedback loops and all that. But, and that may or may not be a good thing to do depending on the circumstance, but I find that it's often helpful to think about things in that manner. And then we had a more sophisticated dealer sector that we've been working on, right? And if you'll recall, these are modules, I call them sectors. They're the round-edged little icons up here. When you connect these wires, you're telling Stella, if you remember, that these sectors, these modules are interacting with one another. And you've got to, if you do that, you're going to get the little warning sign. If you don't, see, I got the map view up here. There's no warning signs. You know, if you don't give it some details inside of these squares, right? So we did enough to get rid of the warning signs. Okay, what else did we say here? That well, we went back to our brainstorming about the reference mode, right? To draw the reference mode, if you'll recall, in order to draw this diagram, we talked about important variables or factors, right, that would relate to the problem statement. Right. And then we picked a few, and this exercise is nice. This Saul Friedman article is nice because there's enough information there to really help you build a model. Like, you don't really know why the problem is occurring according to the article. That's not murky. And it kind of describes vividly the sequence of events, right? The police seize the heroin supply goes down, therefore the price goes up, therefore the poor addicts living in poor neighborhoods have to commit crimes to get enough money to buy the heroin to feed their habit. And they got to commit a lot of crimes because any one crime doesn't yield a whole lot of revenue, right? So you're told that in the article. So it wasn't that hard to identify, you know, some important factors and the sequence of events, the chain of events, the dynamics of the problem. And we were able to draw this diagram. And we said, you know, sometimes you don't want to start a model in equilibrium or have your reference mode be an equilibrium thing or starting in equilibrium, because we know real systems don't exist in that state unless they're dead. But in this case, or I said my rule of thumb is, if the sequence of events that are a description of the problem occur due to a shock, something has happened suddenly that was unanticipated. You know, a tanker, a ship wedges itself in the Suez Canal and disrupts the supply chain, as a year or so ago happened. That was unanticipated. There's the orange crop freezes overnight in Florida, unanticipated. A central bank somewhere does something extreme with interest rates that was unexpected. What have you, right? And then that causes whatever the problem is. So in that circumstance, I would consider starting the model in equilibrium and shocking it out, and then the dynamics are the reference mode, right? So it's not always done this way, but it's sometimes done this way. Okay, so we had this as guidance, right? And then, and then the point I wanted to make was then, so we said, well, let's pick one thing here in the sequence of events. Well, the police surprise the drug dealers, bang, they bust in, and they seize the heroin. So there was a dealer heroin inventory, right? And we said, well, is that a stock or a flow, right? And we said, oh, it's a stock. How about the seizure rate? That's a flow. And that was enough to get us going, right? So we said, here's our heroin dealer inventory, and here's our seizure rate. We really didn't do much with this. If you remember, we just said we're going to make it 0 at the moment over here, just to, it's there. We know it's there, but we haven't done anything with it yet. Then we also asked the question, are there any other flows that would be involved here, right? And if the police seizing the heroin caused the drug lords elsewhere to abandon that location, Detroit, then there would be no inflow. Once the stuff is gone, seized and or consumed, nothing arrives. But if the drug lords say, oh, they got our current wave of underlings that handle it for our business for us in Detroit, we'll just replace them. Their lieutenants move up in the organization, and we'll just resume our operations, which is presumably what happens. We have an incoming flow of new product, the acquisition rate, and of course, in addition to the stuff being seized, it is consumed, right? So we were able to identify some flows to go along with stocks, right? We also were aware from the article that the heroin is measured in bags. So trying to keep it, in harmony with the article, or we'll go with that rather than kilos or, whatever. And of course, if these are in bags and the model over here is in months, right? Well, then the flows are going to be in bags per month. And Stella automatically does that for us very nicely. Okay. What else did we say? Well, we said that unlike molecule number 2, which was the one where we have the decay, right? That's like an ice cube melting on a hot driveway in Mississippi in August, right? Or the diffusion of a drug through a person or an animal, the depreciation of plant and equipment, radioactive decay, the time value of a derivative financial instrument going away. Just by existing, the thing starts to go away, right? It starts to rust away, become obsolete, melt. Time is ticking away. In that case, the stock itself causes its own demise. The very fact that the ice cube exists means it melts. But in this case, there's something different that we didn't look at with our original molecule. Something is pulling out of the stock. Well, what's pulling out of the stock? The dealer's inventory. Sales to the addicts, right? So we said in order to determine this flow, we need addicts coming from the other, modular sector here. Remember, we said we said this is going to provide output. And where's it going to give output to? Well, the only place there's an arrow where it can go would be over here. So over here, we said get down to stock and say we're going to have it accept input. What input? The ADDX from the other sectors. So that's in some sense a way to link the sectors, the modules, or provide a copy over there, if you will. And so you need the number of addicts times the monthly addict heroin requirement. So each addict uses how much product per month. The model's in month. Why is it in months? Because that's what the article was about, right? Okay. So if you multiply number of addicts times bags per addict per month, that would be the number of bags per month that they would like, that they desired heroin sales rate. Now we draw a distinction between what you want and what you can actually do, because in this case, if there's no heroin or it's a limited supply, you're almost out, you can't always have everything you want, right? So another way of saying that is we applied first order control to the outflow from heroin sales, right? So what we want to say is, yes, if there's enough stuff in here, sell it to these guys, give them what they want as long as we have enough. But as we start to lose product below what we need to satisfy our customers, we have to start cutting back here. You have to start rationing it. Maybe you can only buy half a bag. You want a full bag or whatever, 4 bags a month. You can only get, half of what you want. You might have to go to another city or something, to the suburbs or whatever to get it. And of course, this table function says, so when the ratio of in this case, the desired inventory to the actual inventory, when that ratio is 1, then give these guys everything they want. When the ratio of this to this is 0, right? Because the x-axis on a table function should almost always be a ratio. So in this case, we have heroin inventory over desired heroin inventory, right? We got the double slash as a safe division, and we don't want to divide by 0 inadvertently. If the denominator can move around, we want to make sure we always do that so we don't get in a weird situation where it goes to 0 and blows up the model, right? So when that ratio is 1, let her rip. When it's 0, it means there's nothing in the inventory. Stop selling it because there's nothing to sell. And so selling it when there's nothing to sell, it'll do it mathematically, but you'll have negative inventory, which is no good, right? You could interpret it as backlogged orders if you wanted, but that's no good, right? So my point is we added a feedback loop here for first order control, if you remember. So the equation here is desired times the effect, the first order control effect. So when the effect is 1, actual heroin sales are equal to desired heroin sales. And as you start to run out, then you start rationing it. It's going to be something less than 1 times desired. And then when there's nothing, it'll be 0 times desired, right? And notice how we graph the desired and actual flow on the same graph on the same scale. So if they deviate, we can see what's going on, right? All right, so how did we determine how much heroin the dealers would like to have on hand? And this is a common, and how do I know to do this? Well, we said that this is a generic structure. This would be a real typology going back to Hume versus Descartes, right? That the detective or the physician doesn't go in with no knowledge, a Vulcan mind erase, and they see a new patient or a new crime scene and they have nothing as a reference point. No, they got some principles of systems, principles of economics, generic structures, real typologies, patterns that they've seen before, right? So this is a well-known formulation in system dynamics for it's called ordering functions. When you don't have enough of what you want, you need to order more. Okay, you can order it from yourself. You can make some more of it, or you can get it from somebody else who's going to make it or supply it to you. So it's kind of starting a supply chain management kind of thing here, right? It's almost like a beer game thing, or if you were managing the supply of anything for a corporation, this would be the kind of thing you would start to build. So in light of that, we said that a way to determine how much inventory you'd like to have in supply chain management is to say, well, what am I losing typically? How fast is my stuff going out the door? My widgets, how fast are they going out the door? What is my average sales rate? Okay, it's because it can be bouncing around. So typically, what am I losing? How quickly am I losing my stuff? And then the desired heroin inventory coverage is a time constant, a time idea. It's not how many widgets would I like to have on hand. It's how many months worth of widgets would I like to have on hand. I'd like to have 2 weeks worth of stuff, or 2 months worth of stuff, or 1 month worth of stuff, whatever, right? It costs money to maintain inventory, right? So, you know, somebody who's managing a supply chain is going to know that, and they're going to have something in mind, like, because you don't want to be stocked out, right? You don't want to make a customer mad. They come to buy your whatever, and you don't have any, no good. They go to your competitor, they might not come back. So you don't want to be stocked out, but you don't want to be needlessly carrying inventory because it's expensive, right? So coverage is a common idea, and that directly relates to Little's Law. The idea of, I don't have it in here right now, but remember, if you take the stock and divide it by the outflow here, we did that, you get the average residence time of a unit in the stock, right? So that's kind of, it relates directly to the idea of coverage. So you could plot on the same graph, on the same scale, desired heroin coverage, and then average residence time, and you could see if what your actual coverage is relative to what you'd like it to be. Okay, I don't think there's a need to do that here, but you know, you could do that. And if you look in the national income and product accounts in my field of economics, you'll see sales to inventory ratio. I mean, it's the exact same thing. They just call it something different, but it's a common measurement. Okay, so in order to get how much would we like to have in here, what we do is we multiply the average sales rate, or the average rate at which you're losing something, right, times the desired coverage. So this is in months. This is in bags per month. So bags per month times month, months cancel, and you're left with bags. This is how many bags I'd like to have, given that on average I'm losing the stuff this quick, and here's how many months worth of stuff I'd like to have on hand. Here's the coverage I'd like to have. So then you make that into a ratio over here as the x-axis of the table function. Okay. Then we said, you know, I purposely was showing you some steady state error stuff 2 or 3 or whatever weeks ago, where I did something like this. There wasn't a seizure rate, but I had a step function in the sales rate, right? And I showed you the railroad tracks. And then I said there's a fix in system dynamics for this. And I said the first thing you have to do is correct for the gap between what you want and what you got. So that's what's happening right here, right? It's what I want minus what I've got divided by tau. So that's a proportional control structure, right? Close the gap between what you want and what you got. The bigger the gap, the more corrective action there is, right? Plus, you have to replace what you're losing. That was the steady state error example. So if you go back and look at those tapes or look at your notes, whatever you did, you'll see that we did this exact same thing here. We said it's correct for the gap between what you want, what you got in your stock, and replace what you're losing. But typically on average, you replace it. Remember, we used the step and we said, well, if you just said, give me the sales rate, then you would, in that example, you were anticipating the unanticipatable shock. So he said, really, the answer is to average it. And we don't want to add negative widgets to our negative bags of heroin, I should say, to our inventory. So we want to get rid of inventory through sales and seizures, not through adding negative bags of heroin, where you go in and throw buckets of water on your bags of heroin and ruin it or something. You could do that, I guess, but you don't want to do that. Okay. And again, how did I know to do this? Well, I recognized that this is an ordering function situation, and this is a very simple kind of system dynamics ordering function that's well known in the field. They can be much more complicated than this, but this is a fairly straightforward and fairly easy to understand formulation. Okay, so I didn't invent it. I'm familiar with structures that are useful, real typologies, generic structures that are already in the field that others have invented. And, you got to know their limitations and whatever. You might have to tweak them. The standard formulation of this ordering function does not have a seizure rate in it. So that's a tweak to the standard stuff. Okay. And when we ran this thing, we just wanted to make sure we were in equilibrium because we're going to shock it out, right? So here we have desired and actual inventory. And a good idea, I think I said, is to put these things on different colors and different line thicknesses so you can see whether or not these things are on top of one another, right? So we have desired and actual, and here we have desired and actual, and even the acquisition rate. We have the inflow rate, and they should be all the same. The seizure rate's 0, so it would be down. If we plotted it, it would be down there. So the inflow equals the outflow, right? And the outflow is at its desired rate. Okay, so this is kind of where we left off. I just wanted to make sure we're cool with where we're at. So the next step, it seems to me, is to say, all right, the thing goes into equilibrium. Cool. That's what we want. Even if ultimately we're going to not ever start it in equilibrium. We are in this case, but even if we weren't, it's good to be able to do this so you can test to see what happens when you ping the model with something. You ask the question, is it doing something stupid, or is it doing what it should do? Okay. So we got to knock this thing out of equilibrium. How to do that? So again, there's, you just have to kind of do this for a while, I guess. Think about it, look at what others have done. But I would say you could make a variable here called heroin seized. That should EI, I think it is, right? And you'd probably want to put fraction of heroin seized. In other words, it's unlikely they get everything, the cops, right? So, and in a more sophisticated, so you can often be sort of planning for the future. So we'd say here it's inventory times the fraction seized. You'd want to say to yourself, all right, later on, if I wanted to add a law enforcement sector, we brainstorm that. If I were to do that, what might that look like? Like, how does this work? And you might say, well, the police, they just don't seize every day, not these big raids. They might seize stuff when they stop somebody on the street and frisk them and they find some. They say, oh, what's in the movies? They pull it out of the guy's pocket. Say, what's this? And then the guy says, that's not mine. right? So, but a big raid, they have to be planned and they have to be coordinated and they have to gather information. So they have their snitches out and all that stuff, gathering intel, right? And so the better the intel, the more effort they put into gathering intel, maybe the longer they wait, the more they're going to seize. So you could have that kind of stuff in the model. If the chief of police were the client, you might consider that kind of stuff. So in anticipation that we might have something like that, we're not going to do that. I'll tell you right now, we're not going to do that in this class, but just the kind of thing is you can leave little stubs in the model that might be where you could expand the model later if you so chose. Okay. Now, I have no idea when they typically go in and seize this stuff, how much they typically get. I mean, it might be like a coin flip 0.5. So, it's half of what the dealers have they get. And you can play around with this. It really doesn't matter. Okay. And so certainly the amount you're able, you see, or whatever, or, well, you got a warrant for my house, but you didn't get a warrant for the trunk of my vehicle, so you can't look there legally, this sort of thing. You're not gonna get it all, presumably, I guess. Now, what we like to do in system dynamics a lot, at the risk of stating the obvious, is turn things on and off, right? So we could put a switch in here, perhaps. And so we can turn things on and off, and we can make it a 1 and 0 switch. So when it's 0, the seizures are off. And if it's 1, the seizures are active. Okay. And I'm going to show you something that I goofed around with here. I think it's kind of neat. Seizure interval. Now, how quickly or quickly, how often is a better way to say it, do the police do their raids? And let's put in a switch for multiple seizures. So obviously I've thought about this ahead of time. Depending on the circumstances, I might not have thought about it ahead of time, right? But in this case, I did. So I like to color code my switches just so I can see them and say, all right, I got a switch in here. Okay. And again, switches are 0s and 1s. You know who loved putting switches in his models was Forrester. He always had switches everywhere. It's funny. He never used causal loop diagrams, but he always had switches all over the place with his models. Okay, so what else do we have going on here with these two unspecified variables here? And I'm going to, we are 48. Let's make this 12 months. This is what I did ahead of time. If the switch for multiple seizures equals 0, then 100, which is bigger than 12. What I wanted, however long the simulation is, right? I just made it 12 here. I want to make this number bigger than it. And if I want to expand from 12 to 24, I don't want to have to goof around with this. I just made it a big number. You could make it, 1,000 months. You're just taking it, if the switch is 0, don't activate on any reasonable time interval. 1,000, we're going to do it 12 months, 24 months, 36 months, 48. It's not 1,000 months, right? So takes it out. Else 12 times a uniform distribution. Okay, so 12, where's 12 coming from? That's the length of the simulation. And the uniform distribution generates, it's like the Polya process with the vase with the different colored stones. It's every number from 0, in this case 0 to 1, I put a 0 to 1 in there, is equally likely. Okay, times 12. So it's saying what month do you get the seizures on? Okay, and if it's 1, okay, then it's going to be triggering 12. It's a 12-month simulation every time there's a random number times 12. So if it's a 1, if it kicks out a 1, it'll trigger in the last month and so forth. If it's 0.5, it'll trigger it in 6 months in, right? All right. And then the other thing I said here, instead of turning that off, I said, all right, so this one's a little tricky. So this says, all right, if the switch for heroin seizures is 0, turns the whole thing off, right? It zeroes it all out. If it's 1, okay, it's going to activate this thing. It's going to activate a pulse function. And a pulse function is going to blip up and go immediately back down in 1 dt. If I right click on here, okay, there's the volume of the pulse. How high does it pulse? Okay. When's the first pulse occur? And what's the interval? You want it pulsing every 2, every 7, whatever. You can make the interval a bit really giant number if you only want 1 pulse. Okay. So we said first pulse would be 2. Okay. And then the interval would be the seizure interval, which is this, which is coming from a random number generator. So if you don't do something like this, then it always pulses on like a clock. And guess what? The drug dealers quickly learn, oh, it's the Friday of the second month. It's been 2 months. It's been 8 weeks since they always come the Friday of the first week, and we're ready for you. And we hide the stuff, right? So you want some randomness in there. Now, again, a lot of it would be a function in a more sophisticated model of the police's when they're ready to go. Like, have they got the intel? It might have been X months since last we raided, but we don't have any information, right? So, it just all depends. So I just try to make it a little more interesting here. Have it generate randomly if you turn it on. Okay. So you can have 1 seizure or multiple seizures. If multiple, it's going to come randomly. All right. So let's pause there. Somebody's got their hand up here. Suzanne, what's up?
So my questions are just a couple of mechanical questions. Back down here, where you had your initial dealer heroin inventory, how come the arrow doesn't go the other direction towards the desired?
Okay, so I was being really, really, really transparent there, possibly needlessly so, and maybe it's made the waters more murky. If you go to my style is to initialize my stocks outside of the stocks.
No,
so,
I understand that. But why does this arrow not go the other way towards desired dealer heroin inventory?
Because I want my initial value of my stock to be what I want so that the model starts in equilibrium.
Mm-hmm.
There's no need for me to do anything different if I have what I want.
Okay.
Right.
The other thing okay, I got it. The other question that I have is when we're trying to determine what the fracture heroin seized, wouldn't that fraction be based on the total amount of heroin that we estimated that's in a geographic location? Or is it, how do you determine what the whole is when you're talking about fraction heroin seized?
As I said, it probably is way more sophisticated. It's more like a stub. I'll sometimes make my stubs in a different color.
Okay.
So in other words, I'll say if I see blue, sometimes I use green, I'll say, aha, I might be hooking something up here later to make it dynamic.
Okay. Okay.
The red is I use typically for switches, and blue or green, like just reminding myself that at least at some point I or somebody I was working with suggested that, hey, that thing, that fraction seized might be a variable, it might change based on this, 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 and this.
Okay.
My response is typically like, good to know. Let's keep that in our hip pocket, but let's keep it as a constant for now.
For simplicity.
For simplicity, and let's
Okay.
later on think about, like, if we start playing with the model and it's very sensitive to this, then you'd say, all right, there, that might be a leverage point, so we might want to think about
Okay.
expanding the detail there.
Okay. That makes sense. Thank you.
Okay, sure. All right. So so what have I, so I've got two switches here. 0, they're both 0. Yeah, they're both 0. So I should still get equilibrium. And I do, that's good. Again, I don't want to wait forever to test to make sure everything is cool. And I would normally be like the, you know, these things I prepared ahead of time, these equations here. So it took me a while to figure that out, and I would be just playing around with it. So it seems like, oh, he just knows it. No, I didn't, but I didn't want to in real time, like, not know it. And then we sit here for an hour, me trying to figure it out in real time and talking about what I'm thinking of, and I'm not even sure. Well, let's try this, right? So again, it's a little bit of a simulation of how you would really do it, right? So I had figured that out ahead of time. So, all right. So anyway, so let's turn on the seizures, and we should have, I made that a 1. We should just have one seizure now, and hopefully it'll look something like this. Right. So we have heroin price. Well, we don't have heroin price in here yet, or crimes, but at least the seizure rate and the inventory. So that would give us some indication that we're hot on the trail. Okay. So what do we have here? We had the sales rate, right? What do we got here? The acquisition rate, so the system responded quickly. You know, we could say, you know, maybe it shouldn't respond as quickly. So we can, depending on what the drug overlords think, right? Or hit the U-turn and put it back to where it was. Okay, so what we don't have on here, on this guy here, this one here, because it has flows, is the seizure rate, right? Because there's a bunch of flows here. And you can see there's the big boom, right? All right, so what do we got here? Switch for seizures, heroin seizures, pulse, and interval. Okay. All right, how about if we say we want multiple seizures, randomly determined. Let's run it. Now, I didn't put a seed value in there. So every time I run it, it's going to be different. So look at over here. This time you had 2, one right after the next. If you want to have randomness, but it's always the exact same random pattern, so you can compare things, then you got to give the function a seed value. So you see where it says seed here? It can be anything you want. It can be 1, 2, 3, let's say. And if you do that, then it's going to always give you the exact same pattern of random numbers. If you change the seed value to 4, 5, 6, it'll always be the same pattern of random numbers, but different random numbers from when you did 1, 2, 3. So that way you can compare runs. Okay. So what we have here is the, you know, the surprise thing happening, right? And it happens, we can have it happen randomly if we want. You know, we could probably, let's see, you probably even have the single one. Heroin seizures, turn it on. Seizure interval. Yeah, I'd have to play around with this a little bit. You could change it so that the single interventions seizure rate, it always is going to happen at the same time. But you could say, let's make that random. Again, it doesn't really help us in this case, I think, but you know, we could consider doing that and making it when there's only one, it'll happen randomly, right? But let's not waste a lot of time on that now because that doesn't help us very much. Okay, so notice up here, the shock knocks down inventory, right? So we started initial desired. What is desired? Oh, 4,000. Okay, so see that it worked? So we started with 4,000 bags in inventory, and we said, let's get rid of half, 0.5. And look at here, it went down to from 4K to 2K. So it got rid of this spike here, given the DT is like 20K. But you can see here with that's a numerical thing, but with the inventory, you can see it went from 4,000 to 2,000. So they got half of the supply. Okay. If we said, you know, if we wanted to get 3/4 of it, I'm so close. Come on now. So you see they got 3,000 of the 4,000. They got 3/4 of it. So that works. Okay. So so far so good. We can knock it out of equilibrium, and you get the let's see, heroin inventory is in red here, and it drops and then it recovers, right? Boom, boom, and recovers. That's what's going on here, right? So that's good. And we got this pulse, this seizure pulse thing. And that's in green and pulses, right? Okay. So it doesn't really have this smooth thing here, but that's okay. I think we're doing fine. Okay, so what's the next step in the story that we read in that article? So the cops are surprised, bang, and they burst in, they seize half of it, whatever, right? And they arrest the dealer, whatever they do, right? They have a news conference and they got a pile of drugs, a pile of money, a pile of guns. The mayor is standing there. The chief of police is standing there. The arresting officers are standing there, and the cameras are rolling and all that stuff, right? But what's the next thing that happens? What is the consequence of that happening?
Is it price?
Yeah, exactly right. So in return for your success as a law enforcement person, you're going to get more headaches. You're going to get more crime. Okay, so let's put this down here. Okay, so how to do that? Well, we probably want to put in heroin price. Now, one way to think about doing this, I don't think it makes sense here, but just to call your attention to it, we might say that we could make subsectors here. We might say, you know, I want to grab one of these guys here and call this the inventory or dealer inventory subsector. You know, if you go up, these are sectors, right? We drill into a sector, we might have a subsector here. This might be dealer inventory subsector. Then we might have another one, which would be heroin price subsector. And they might interact, right? So you can have hierarchical, like you go from the first floor to the basement to the sub-basement, the sub-basement, right? That kind of thing. Now, I don't think that makes sense here, but depending on what you're doing, you may want to modularize your model further than just this very high-level modularization. Okay, and we have the construction warning symbol there because this is not defined now, right? But I think it's more illuminating to not put in subsectors and just have things that are just on this electronic paper, although I could be wrong. Wouldn't be the first time. So we can call this heroin price. Now, remember when we did the PowerPoint slide deck and the presentation on identifying stocks. And we talked about stocks send out signals. There's the, you know, if you conceptually stop time, flows would disappear, stocks would remain. Flows are like the movie. Stocks are like if you stop the movie, but the projector light was still on, there'd be a single frame, right? Various ways of thinking about what's a stock and what's a flow. I think I remarked at that point, as an economist, I can tell you prices, interest rates, wages, they're all sort of prices. They all send out signals to the marketplace. So I'm inclined as an economist to almost always represent a price, a wage, an interest rate as a stock. Now I can tell you somebody as prominent as Dennis Meadows in his doctoral dissertation on commodity cycles represented price in that circumstance. Dennis knows all this, not as a stock. Barry Richmond, when he was alive, the inventor of Stella, would have a whole thing on should prices be modeled as stocks or not, and it depends. Usually yes, but, and whatever. So these are guidelines, rules of thumb, heuristics, things that are useful most of the time. But I think in this case, what we want to do here is use a buy flow. Okay. And so the buy flow is a net flow. So we're not gonna drain the stock with an outflow or outflows. We're going to fill or drain the stock with one net flow. Stuff can go both ways. It can add to the stock or drain the stock. And I'm going to call this change in heroin price. So this could be a wage rate, change in wage rate, interest rate, change in interest rate, that sort of thing. Okay. Again, there's no one, there's not like there's only one way to do this and Mike's way is right and everybody else's is wrong or anything like that. This is just how I think about it or see it. Okay. Now, in this kind of formulation, what we would typically do in system dynamics is say, indicated whatever. Whatever the stock is, it happens to be heroin price. So I said indicated heroin price. How do I know to do this? This is another molecule. You'll see it's the same molecule. It's molecule number 3, but just a different sort of interpretation of that molecule. So what I want to do here is use that third molecule. We've already used it, by the way, in here. It's right here. It's right here. See, we got the buy flow. We're going to use it again, but it's not an averaging. Well, it is, it's mathematically all the same, but the mental interpretation is not that you're smoothing or averaging sales data. Now we're trying to say when prices are, there's pressure to change price, price doesn't instantly change. There's an indicated price from the pressures in the system, and then price gradually adjusts. Meaning, if you're a retail store, you might have to go around and put new labels in the days when you'd stick labels on, or new barcodes, or go on the computer and change the price associated with a particular barcode or QR code or whatever, right? So you can't just instantly change things, right? My style is also to say, you know, I would say whatever's in here, I'll copy it to the clipboard, then say initial, paste, initial heroin price. So what's our initial heroin price? Does anybody know? Does anybody remember from the article?
$7 a bag.
$7 a bag. Thank you. All right. So we could say 7 if we wanted to say, you know, dollars per bag down there. So I'm going to open this and say INI, and I want the initial value of heroin price to be initial heroin price. Dollars per bag. Okay. So this is initialized to that, and that's $7 a bag. Okay. Now, again, when you're doing these things, it's useful to think a little bit ahead and to say, can I reuse things? And I probably did this, you know, I did it already. I could have maybe done this a little, this is a little clunky, but if you look here, I made the ratio of inventory to desired inventory, right? So I did that inside of the table function here. Better, I suppose, would have been to do something like this and say, heroin inventory ratio, right? And I can say dealer. In small models, it doesn't matter, you know what it is, but with a large model, it's like if you have several inventories, it's like, whose inventory is it? Is it the addict's inventory or the dealers? You know, even in this model, you can be confused. So always is good to be transparent, I guess. So in this case, let me move this out of the way. Sometimes things get cluttered and you just have to just say, I'm going to move things out of the way here. Okay. So I could have specified this ratio and then ran it into the table function, but I didn't. I guess I probably should have, but I was doing it in real time. So, you know, I guess that's what you get in real time. But so I just made a copy here. Again, I don't like crossing my lines, my wires. I could do that. I could just run a wire from here to here. But let's have probably inventory / desired inventory, because desired inventory can move around. So I want to inoculate myself from the denominator getting to be 0. So I have the ratio now, and it's the same ratio that's in here, right over here. So, you know, I probably could have defined this and then gone like this, but I didn't. So it's sort of redundant. Oh, well. And then we'll run this over here. So remember that this ratio is kind of a supply-demand ratio. right? When that ratio is 1, the dealers have what they would like to have, right? If it's bigger than 1, they have more than enough. And when it's less than 1, they're short, right? That ratio. Now, I've been talking about in the past how we use these table functions in system dynamics as kind of the signature way of representing nonlinearities and what have you. But I'm an economist, so I sometimes can't help myself. My econ hat goes on. It's not that my system dynamics hat goes off, but my econ hat is on. And there's a concept we have in economics called elasticity. And elasticity is sensitivity. It's basically the percent change in this causing a percent change in that. So if a 1% change in this causes a 1% change in that, then it's kind of of unitary elasticity or sensitivity. If a 1% change in this causes a 10% change in that, it's very sensitive. It's very elastic. And if a 1% change causes a 0.5% change, it's inelastic. It's insensitive, right? If it's 0, then there's no relationship. Okay. Now, what I want to do is I want to make sure that when I'm short, when my inventory ratio goes down, which means I'm short, I have less than I want, what way does my price go? Ratio goes down, I have less than I want, price is going to go
Up.
up. Absolutely. So that means my elasticity has to be sensitive and negative. It has to go in opposite direction. I just picked 2 arbitrarily. You could econometrically estimate these things if you wanted to do that. It really doesn't matter. But the equation here, this is right out of basic economics. We'll just take the initial price, and then we're going to take that ratio, and we're going to raise it to the price elasticity. So that's right out of a microeconomics textbook. Okay. It kind of, you could kind of do the same thing with a table function, but this thing is, just wanted to illustrate how you could do an econ thing directly in here. And then prices don't change instantly. You could say time to change heroin price. And you can make this, however many months you want. It's smooth. The bigger you make it, the slower it changes. And then it's that same molecule. It's indicated price, that's your target, minus the stock divided by tau. So this molecule is molecule number 3. Same thing as this guy right here. Same thing as desired arms for country A, arms for country A. We've seen this thing a gazillion times. Remember we said that 3 of these get you 95% of the way to the goal, right? Remember all that? So at this point, it probably makes sense to run the thing and see where we're at, so we can run the thing. And we had a spike there. Let's get rid of that just to make room here. And, if we put price on here, and we want to put it on the right-hand side because it's on a different scale. So see where I say right axis there? Now you can see it. And again, we would be ideally, if we're really doing this, we're always referring back to this. That's the thing that's motivating us, right? We want our base run to look like this. And see, where's heroin price? It's in the cyan color, right? And you get it up and down. We hypothesized, kind of doing that, right? I mean, we could make it, if you really wanted to go hog wild, you could, do this sort of thing. I can't remember what the other colors were. What do we have here? So heroin inventory was what was red. We had Cion. I mean, you can get as crazy as you want with these. There's red and Cion, right? Okay. Now, there is a difference between the price changing and the price being recognized by participants in the markets. If you look at any of Jay's models, he took great care to do this. He would say delivery delay recognized by the company, delivery delay recognized by the market. And there'd be these delays before the information gets out there. Okay, so delays are very important in the system. In fact, if you go here, we took great pains to you can see that the price went up. We didn't have perceived price in here, but you see the crime rate went up and peaked after the price. And we did that purposely, right? We said they're not going to go up at the exact same time because first price has to change. The drug lords have to decide we're going to raise prices. Then they have to get their people together, tell them it's more expensive. Now go out to your customers and tell them this. That takes time. And then the customers have to say, I got enough for 2 bags. I'll come back to you in a couple of weeks. In the meantime, I got to go commit some crimes. So then the crime rate starts. So it doesn't all happen simultaneously. So it's not just the shapes, but the shapes in relation to one another, right? So how might we say, all right, so we got to kind of delay this thing to represent the heroin price perceived by the market or by the addicts. Now, you could do that, and Forrester would do this by just replicating that molecule and running one molecule into the next molecule to make a second order information delay. We get into all these delays in egregious detail in the next course. And for now, we could do that, but we're not gonna. I want to just show you some other things, particularly if you're a more advanced modeler. You're going to know this and say, all right, I don't need to explicitly lay that out because I've done this forever, so I want to save time. So what you can do instead is go in here and say, all right, I'm going to use my functions over here, my canned functions to help me save time. Okay. And you can see that there's these smooths. These are information delays as opposed to delays. See where it says delay? Those are material delays. We're delaying information about price. So, and let's make it a first order. Again, we'll go, if you take the second course, we go into all the mind-numbing detail about all the different kinds of delays and when you would use them and whatever. There's a hand, somebody's got a hand up. Suzanne's got a hand up.
So this is kind of a Stella thing. I have seen that they have this little dotted connector. Is that, my understanding is that's for like information delays? Is that
you could
way to represent them?
Yeah, you could info connector. I don't use those. That's in the old days, if you look at Industrial Dynamics, the first book, Forrester has for all different kinds of information, money versus people versus information. He has a different kind of wire. I don't see the need to do that, but you could. Yeah. Good question. So the smooth here, if you jump to the definition, you want an input. And what are we delaying or smoothing? Price, because it takes time to get to the market or to the customers, right? Then averaging time. Now we could, well, let's do that. We can make it explicit. We could say, time to smooth heroin price. Again, if you're a veteran modeler, you're probably not going to this much detail. And we should be saying here, you know, I'm a little sloppy on my units, in the interest of time. And then in here, you'd say time to smooth, right? You could give it an initial value explicitly, which we typically will start it in equilibrium. So it's, you know, it's whatever the thing is being delayed, you start it there. You don't have to, but that's the typical way we would do that. Okay. And, oh, you know what I should have done, sorry, my bad. We should have used delay converter. This is the exact same thing. It's just the converter tells you that there's a stock inside of there. So see, now it's got the little square thing on there so that there's a stock in there. In other words, I didn't bother to build this structure. It's in there just to save time. So I just wanted to show you that, just something that a more veteran modeler would do. Okay. So at this point, it might make sense to copy and paste this and then get rid of that. And over here, get rid of this. So let's keep the one on the one, and then over here, oh, it's on the right axis. Let's get it off the right axis. And then we can add heroin price perceived by addicts, and let's run it. Okay. So you can see there's kind of an over and undershoot that's going on here. Now we might have some steady state error in here. I'm not sure. Again, I prepared this ahead of time, but not completely. So I'm not sure. Sometimes you get, now it's taken care of it. So, but it's good to check. Did we have steady state error, right? What I have here, 12. Okay. All right. So same graph, same scale, looking at the delay, right, in the system. All right. So what's the next step in the story? Everybody's hanging in here. What do we got? 725 or something? How are we doing? Nobody's
Good. Good.
Nope.
Next step would be the price equilibrates after the seizure, goes up, then comes back down. Then there's more.
Well, okay. I mean, it's doing that, right?
Okay.
Okay. So,
More-
but in terms of the story told by Saul Friedman, what's the next steps? The police seize the heroin, right? And then the supply goes down, price goes up, price, I guess you'd say, perceived by the addicts, by the market goes up. The addicts say, I can't afford this, but I need this. So they start committing crimes. They have poor neighborhoods, so they got to commit a lot of crimes to get enough money. So the next step is, the next missing piece of the story is
more drugs get shipped back in and makes the price go back down.
well, all right. But while it's still up, I mean, it's over here, it's up for a while, right? That's
Well, we've already
like
said
a year and a half.
the crime rate goes up.
The crime rate goes up, right? Because we're always referring back to the reference mode, the problem statement, right? So the next chain in the sequence of events is the higher prices perceived by the addicts or offered to the addicts requires them to commit crimes. Okay. So how might we do that? Well, one thing I was thinking about was, we could say something like required monthly cash. Okay, so how much cash or money, whatever you want to call it, would be required by the addicts? Now, in economics, we often talk about the nominal economy and the real economy, okay, or the money economy and the real economy. So the real economy would be bags of heroin, dealers, addicts, police officers, and what have you. The money economy would be the financial representation of all those things. Okay, so we have the physical desire for heroin, okay, and we want to convert that to the money desire for heroin, right? So this is, given that there's this many addicts, because it's the addict sector, it's not an individual addict that we're modeling. And given the average or the typical monthly habit, this would change, big people, small people, men, women, whatever, different sensitivities to the stuff and what have you. But on average, here's, what did I say? 4 bags, whatever I said. So this is every month. This is the physical amount of stuff, the bags per month they'd like to have. So required monthly cash would be the amount of cash they'd like to have to buy those drugs. Okay. So this would be in terms of bags per month, right? And this would be in terms, this is your price. So we have the heroin price, which is dollars per bag. And then we have bags per month. So dollars per bag, bags per month. If you multiply dollars per bag and bags per month, the bags cancel and you get dollars per month. Yes? So see how your dimensions help you? If you multiply bags per month times dollars per bag, you get dollars per month. And that's, of course, where your units check would help you, right? Okay, so let's, oh, I shouldn't have done that. So let's just undo that. What I wanted to do was this. Okay, so it starts in equilibrium, and then there's more cash that's necessary per month, and it's going back down. So that seems to me to be a good thing. Okay, so now what might we do? Again, you have to think, this is the place where I think the units really help you. So this is the amount of cash the addicts need per month. Now, and for some reason, I was typing like crazy and it didn't take. So let's try that again. So if you want to get into sort of the socioeconomics of this stuff, you know, are the addicts well off or not? Are there victims of their heroin-related crimes well off or not? Hence, they have to commit a lot of crimes or not a lot of crimes. They have to commit no crimes. You have to sort of say, well, how might I represent that? Okay. And so this is how I thought about it. I could say required monthly cash from crimes. So here's the amount of cash I need my I meaning the sector, the attic sector. And here's the fraction of the habit financed by crime. So if this fraction is 1, right, and this is going to be the dollars per month times 100%, then I got no other source of income, right? I just got everything is from crimes, right? I suppose there are people who are like that, you know, that they go, you know, they don't have a job or a welfare check of some sort or whatever, but it's probably more likely going to be, I don't know, 50% or something like that. Hard to say. Some of this stuff is, you know, maybe it's 90%. I don't really know. You'd be asking somebody who knows, right? Somebody who works with these folks and could tell you. I think there might be a data set somewhere. I don't know. Okay. So that takes, you know, here's for the whole shooting match. How much does it cost every month? And then do I have other sources of income, or do I have to commit crimes for the whole shooting match? Now, the thing we're really after is the heroin-related crime rate. Now, the word rate is really misleading in system dynamics. I should save this, by the way, because if you think of interest rate, I said a little earlier this evening, I would model an interest rate as a stock. Yet Forrester's original nomenclature, if that's the word for it, was levels and rates rather than stocks and flows. Forrester never talked about stocks and flows. He always talked about rates and levels. Levels were stocks, rates were flows. But I just said an interest rate would be modeled. I would model it as a stock. So the crime rate, what is that? Now, again, I'll circle you back to acceleration, velocity, and position. I showed you could model velocity as either a stock or a flow, depending on what you were trying to do, right? So again, there's just a lot of heuristics, rules of thumb, guidelines here, and no theorems that hold in all instances. But when I hear crime rate, I tend to think of a flow as opposed to an interest rate, where I would think of a stock. Okay, because I would think of, you know, the old movie still photo thing. If you turned off the movie, if time stood still, the crime rate would go away. It would be a flow. All right, so I would call this the heroin-related crime rate. Okay. Now, this is the amount of money the sector needs from crimes, heroin-related crimes. But remember the other piece. So the first is how rich are the addicts? If they're rich guys, price goes up from 7 to 9, they go, ho hum. I don't care. Here's a 10, keep the change. Either way, whether it's 7 or 9, here's a 10, keep the change. But if they're hurting for cash, then it matters, right? So this is half of the battle. The other half of the battle is how rich are the people they're burglarizing, robbing, carjacking, you know, whatever they're doing, right? So I guess we would represent that. A way to do that would say average cash per crime. So that would be a big number if you're talking about robbing rich guys, you know, and a small number if you're robbing poor guys. I think in the Detroit case it was poor guys, so I don't know what you might get. $3 a crime. I don't know. Give me everything in your wallet. And the victim's laughing. Sure. Here's $3. Have a nice day. Maybe it's 5, maybe it's 50. I don't know what the number is here. Some of these numbers I'm just sort of arbitrarily specifying them so that you'd have to play around with the parameterization. Maybe 5 is a more reasonable number. I don't know. Right. So if you had average cash per crime, we said that's dollars per crime. And this is, so cash would be dollars per month. I didn't specify this. So this would be dollars and see, all you have to do is type in dollars and it gives you the list, so you don't have to type everything. Dollars per month. This is going to be, we can call this dimensionless, so it doesn't change the units. So these units will be the same as these units, even though you're multiplying. So these are dollars per month. And then this is dollars per crime. So we have dollars per month, dollars per crime. And over here, we want crimes per month. That would be the crime rate, crimes per month. So I have dollars per crime, dollars per month. What do I got to do? Ideas?
You got dollars per crime and then crimes per month, right?
Over here, we got, so sorry, here, we've got dollars per month, dollars per crime. I want crimes per month.
Hmm.
So if I
So you
take,
cross out crimes and then you have crimes.
so if I
counts
have,
per crime.
if I have dollars per month and I divide by dollars per crime, let's do that. Dollars per month divided by dollars per crime.
Dollars go away.
And you flip and multiply and you get crimes per month, right?
Right.
Okay. All right. Now, remember how we talked about having a scoring mechanism? That might be useful with a system dynamics model, because it's a lot of times it's not obvious like which run is best or which policy change is best, because there's often trade-offs, right? But the easiest, rather than having a multi-dimensional, multi-attribute scoring metric, let's just have a simple one. Let's just say, we'll say total heroin related crimes is going to be our metric. And I'm just going to say 0 here. You could say crimes. And I'm just going to attach it here. So this would be we call this a pure integrator. This is common for a scoring metric in system dynamics, where you're just adding up this flow. You don't need to say an indicated total heroin related crimes like over here. You don't have to do that. Just add them up. So this is not widely used, a pure integrator where the flow, there's no feedback loop. It just goes in there, but it's kind of a stub. It kind of ends there. That's the scoring metric. So we can say the best policy is the one that gives us the fewest total heroin related crimes, because that seemed to be the theme of the article, right? That your reward for doing a good job of getting heroin off the street is you got to deal with all these other issues, right? All right, so we can get a graph up here, and we can put total heroin related crimes on there. We can probably run the thing now. And there you go. Now, notice that there's crimes going on to begin with, because, you know, even at $7, some people are gonna need to commit some crimes. But you can see there's a slight inflection point here. It starts bending up. It's not a perfectly straight line, so it starts accelerating. And, you know, if it's a smaller fraction of their habit, you know, so we can make that maybe 0.5 and rerun. Let me turn this off. Dominance. So now we have a scoring metric. Now looky here. So we're going to go over here. We're going to double click on this graph and we're going to say comparative. We're going to go down here, this little data symbol. I don't know. And there's a lot of runs here. So let's say we're going to keep 3 runs and let's get rid of all these things. Okay. And what do I have here? Search for multiple seizures, 0, switch for, there is, okay. No seizures, no single seizures, no multiple seizures. What happens? Okay. So there's still, there's some of the habit has to be fed by crime. So you have a number here at the end. You can get a numeric display here from up here. See, this looks like an 8. And you can say, make it, I don't know, bigger. Okay. So 33.6 thousand. Now, it was like 11,000, right? I'm trying to remember. So what did I say? Monthly average time to is required cash, average cash. What did I say? This was 5. What if I made it smaller? What did I say here? So make this, what do I have at 0.93, I think, originally. What do we have now? That's a lot. I'm going in the wrong direction now, aren't I? It's dumb. So it was like 11,000 crimes. What am I at? 11.1. Oh. Right? If we go back, 11,000 was the normal. Oh, that's the crime rate. My bad. Sorry. So you got to know stocks and flows. This is a stock. My bad. So that's the scoring mechanism. That's okay. Require monthly cash. Let's get rid of that. What I need, sorry, why didn't you guys catch me? It's the crime rate. That is the 11,000 thing. So what do we have here? We have 914, no. So what do we got here? 0.93, what is this? Make this 3. So better, what is, oh, sorry. So I got 9,000, the crime rate is 9,000. What do I got here now? 10.1. I mean, I'm sort of manually trying to fit this, right? 11.9. And 2.25.
Is the crime rate measured in cash? Is that how it's measured, or is it incidences?
It's incidences. Well, that's the crime rate.
So how how are we adjusting, why are we adjusting average cash per crime then?
I'm trying to get this number to be 11,000. I got 11.6 thousand.
Is that dollars?
No, that's crimes. That's what. And it goes up to 12,000 according to the article.
Right, I remember that part, but I don't understand how come you're changing the button that says cash. That to me, fixing the crime rate has nothing to do with the cash.
Oh, because it has to do with how many crimes do you need to commit? What fraction of your habit is
Okay.
financed by crime? And then when you go and
Okay.
commit a crime, how much do you get? Now,
Okay.
obviously, I'm not econometrically estimating this. I'm just making up these numbers to make it match.
No,
the-
I understand that the reality of this numbers is not important. I just want to know why you're doing the things you're doing.
Okay. All right, good. So what do we got? 748. Okay, so we're doing okay. All right, so we have a scoring metric, right? And so let's do this. Now, a lot of this, once you get it in a gaming format, is a lot easier to do. But here's our scoring metric over here. So I got all my switches off, right? 0, 0. Okay, so let's run the model once. And there's no seizures here. Okay. Then we can say, let's turn on one seizure. And I think that's kind of the base run, right? So what's the first thing you notice over here? And we can go in here and we can say run 2 is the base run and run 1 is don't do anything. Sit on your hands. So if this is our criteria for success, right here, what are we seeing?
We're seeing an increase in related heroin crimes.
Above doing nothing.
Right.
So in that kind of what the article was saying, that you
Right.
think it would be less, they achieve this result. Yay, we got all this heroin off the street, and they get more heroin related crime. Okay. What if they want to seize multiple times, sort of randomly generated? Turn that on. How are we going to do now? Is that any better?
No, you're still having the same effect. I mean, this is a good example of your outcomes are counterintuitive to what your interventions should be. Where's our sector on taxpayer money that goes into this whole activity?
Well, yeah, so we have very little finance in here. There's nothing financing policies. These, at the moment, these seizures are costless, not just in terms of officer salaries and stuff, but when they're doing this, they're not doing other stuff, right? Opportunity cost, as we would say in economics. All right, so how are we doing so far? Is everybody playing along? Oh, one thing, sorry. Where did I get rid of my prices? Oh yeah. So what's happening with the prices? Let's go back to one seizure. In fact, I'm just going to get rid of all these right now. Let's go back to one seizure. How'd my price do? Heroin price went up from $7 to 12. Is that good?
Not if you're an addict.
That's true, but good in the sense of our model. What does our model show? Look at the CN line.
No, it's not good.
Why?
Because it's only supposed to go up to $9. Yeah.
Okay. Okay, good. So it's overly sensitive, right? So what's our sensitivity? The elasticity. So I got to make this less sensitive. So I can use the wheel on this, I suppose. So we'll rerun this. So if I make it less sensitive, see on lines going down. Got now $9.37. $9.14. What I got here? Yep. $8.94. What if I make it minus 1.05? And $9.04. Now we're closer, right? Okay, now how are we doing on our crime rate? Where's my crime rate? Right here. Now I'm above 11,000 again. So if I made this back to 3. And this is what? $11K. Okay, that's fitting the data kind of good, right? Okay, good. So now we're qualitatively fitting the model to the data. We're not using the statistical tools in Stella to fit this data, right? This came from our minds, from a newspaper article. We didn't talk to any experts or whatever, but in light of that, I think so far so good. I mean, we're kind of capturing the story, the narrative, right? Yes, everybody agrees, or yeah. Okay.
Yeah.
Now,
Yeah, I think it's good.
okay. So over here, there's not much happening. Now I'm looking at my clock and we're really running out of time for tonight. But what I would suggest, and we're going glacially slow here purposely, so everybody understand, rather than and you're like, I don't know what the hell the guy did. I got to watch 4 seconds of the tape and then play it backwards and watch it again 5 times. And I figure out, I think, what the guy did. So I'm trying to not do that. I'm trying to go slow, painfully slow, and talk through everything. But we haven't really done anything on the demand side. We've kind of told the story on the supply side, right? If the idea was to mimic the reference mode, and we can make this look more extreme by just changing the scale here, and it would look more like this. The way we've drawn it, it's not as gradual, it's more of a pronounced hump. Not a problem. We can make it do that, changing the scales here. That's not a problem. But does that, if the purpose of the model was to say, we don't know why this is happening, and we've just come up with a reason for why it's happening, we might say success, let's move on to the next problem. But there wasn't really a question of why is it happening in the article. They kind of explain why it's happening. Instead, it's kind of counterintuitive, at least at that point in time. But what the question was, well, what do you do about it, right? And in this sort of situation where you have an illegal activity, whether it's alcohol, drugs, prostitution, any sort of guns, whatever, the question, do you fight on the demand side or the supply side or both? And Ashley mentioned that she had done some real life work in this area some years ago. And so you only have so many resources, right, to deploy. Where are you going to deploy them? Where are you going to get the best bang for your buck? Do you fight on the demand side, the supply side, or both? And where specifically? And do any of your efforts over here counteract something over here, so on and so forth, right? So it would probably make sense to push on and say, can we add some what we call policy space on the demand side? Like, what if we spent resources getting these folks into a methadone program or some sort of facility that helps them kick the habit or at least reduce it, that sort of thing. Or, you could try subsidizing them so they don't have to commit the crimes to, make it publicly available. If you go to the clinic, it's free. You don't have to commit crimes, this sort of thing. So probably we want to continue this next time, thinking about how we might model the demand side and some what we call policy space, okay, and have it interact with the supply side of the problem. And then we can pose the question, if we were going to make this, whatever we come up with, into a game, a flight simulator, so that somebody who didn't participate in this process with us can understand what's going on and get the insights, how would we do that, right? So we'll try, and I think we can probably accomplish most of that next time. And that'll leave us with a class, maybe two, depending on when you want to stop this, to talk about some other models and some other issues in system dynamics, okay? So let me save this.
And I had a quick question as well. I'm running a little behind on my quizzes. When do you want all of those done by for this class?
Doesn't matter, whenever.
Okay.
Whatever,
Sounds good.
whatever suits your schedule. It doesn't matter to me.
Okay.
So
Thank you.
yeah, doctoral students are handled much differently than undergrads. Even master's students are, depending on the circumstance, but doctoral students, very different picnic basket.
Okay, sounds good.
Yeah. So, oh, by the way, I spent a bunch of time today working with Takeda Pharmaceuticals, trying to get some money in here for students. And you wouldn't believe, between their bureaucracy and our bureaucracy, oh my God, it is beyond mind numbing. And well, Ashley's in the service, so she knows about bureaucracies, right? I think we've finally opened a portal where money from Takeda that they actually want to give us can come through this hole in the WPI wall. So we're trying to figure out now how to get it once it's in here, that those Stephen Deans and provosts and stuff don't steal it all before it gets to us, because they'll siphon off everything. You bring in $100,000 and you get 10 grand by the time everybody takes their cut. It's like the mafia.
Yeah.
You got to bribe and pay off everybody before it gets to you. So that's in process, and Takeda wants to do a lot of this sort of modeling and has a lot of projects potentially teed up, including funding an entire PhD student and so on and so forth. So stay tuned. I don't know. I'm going as fast as I can without alienating somebody who can hurt me in the bureaucracy. So I don't know how long, but we've made great strides in the last month. And so if there is a God, some shekels will make it through the system to the complex systems lab. But so if any of you want to be a doctoral student, and want to be funded, there might be that opportunity. Now, Takeda is flexible to a point, but they're in the healthcare business. So they're going to want to see something related to healthcare if they're going to pay for somebody's education. So while they're flexible, it can't be, I want to do, peanut butter and hula hoops. It's got to be something that they would say, all right, that's in our broad wheelhouse here. But they're a Japanese company, so they're international in nature. They want to do things for the third world countries. And so there's a lot of opportunities, but and that's an FYI, a data point. Discard it if it doesn't interest you. Suzanne, you want to do you want to have a PhD next to your Doctor of Veterinary Medicine?
I would.
credential?
I would love to have a PhD in system dynamics as applied to One Health problems. Absolutely.
It could be Doctor Squared. You'd have
Dr.
two of
Squared.
them.
There are a few other people that are Dr. Squared that I know. I
Yeah,
always worry when they have to put all their letters next to their name on their like personal conversations or whatever. It's like, that's always the red flag for
you
me.
need a double-sized business card to get all your credentials on them. I think.
No, I would like to
Yeah.
be able to do that. And I would like to be able to like, I mean, I don't want to give up my current job because I think that's kind of related, but can you do,
Yeah,
can there be any talk of doing that back and forth, or do you have to physically be on
Yeah,
campus to do that?
it's I don't know what it would take or not, and I fear the bureaucrats.
The bureaucrats.
As soon as you say One Health, they'll say, oh, well, that's part of the global school, and the global school dean who's looking for shekels will say, oh, that has to come through my office.
Labels are.
Hands will be.
They can label it
So-
any way they want to keep people happy. Do you do that in the military, Ashley? Like label things differently, even though the functionality is the same to get the job done?
Absolutely. Yeah. Um, I've found it's been a crash course in academia being here on it's a different type of bureaucracy in academia. But it's been really interesting, but I understand it's tough.
So,
Yeah.
so, and Najla, I don't know how what I've just described aligns with your interest. By the way, Takeda has not said only one. They want to do an ongoing thing, and not just with system dynamics. They're talking to the whatever chemists about tissue crap and all sorts of stuff that I don't understand. So they really are interested in working with WPI more, a lot more. So we could have multiple projects, multiple funded students. But again, it would have to, I don't know exactly. The most likely thing would be the global school and global health something.
Mhm.
But as soon as you go One Health, now you're talking the environment interacting with the people, which is interacting with the animals and, and what have you. So I think it's quite flexible.
Global health, and those processes still occur. The label doesn't really matter.
Yeah. But anyway, so I don't have any details now, but we will be, I signed documents today for money, which means it's more likely than not that money will come. This is a first cut it's not enough to fund a doctoral student, but it's a directed research project, and for a graduate student to get paid to do some modeling and stuff. But they're talking, they would like to see some doctoral students be fully funded for their PhD. So, and I don't spend the money till it's here, because I've heard this a million times. Oh yeah, we're going all the way. Yeah. And then they're like, oh yeah, upstairs they killed it. Sorry. So it doesn't mean it's for sure, but it's looking pretty good right now. So just keep it in your hip pocket. And if and when you have an interest in dipping into that trough, and I have a trough, let me know, and we'll see what's possible. And then who knows what the administrators will do, but I can't control them. But they can't control me. They think they can.
That's right.
All right. Anyway, so I got to go, but so we're making good progress. Keep on trucking. We only have a few more classes, so everybody's seemingly surviving here. So, okay.
Very good.
All righty. We'll
sounds
see you
good.
next week.
Thanks.
Take care, everybody.
Bye.
Bye.
Bye.